So you've heard a lot about the background of Webb, how it came to be, some of the people who are working on it or who have worked on it. What I want to talk about now are some of the things that people are actually going to be doing with the telescope, as we call in cycle one, the first year of observations with Webb. So you heard about how we built this telescope to look at the distant universe. Here is a simulation of the early universe where the material in blue or purple depicts how magnetic fields organize matter, and the yellow or gold things inside of them are galaxies forming. And if you watch this simulation, they get larger and larger over time. So this is what we think is going to happen. This is how we've modeled it on computers. But of course, the only way to really know what nature is doing is to actually observe it, take telescopic observations of it. And that's exactly what we're going to be doing. We have programs that are going to be looking for these first galaxies to see how they actually formed. What you see here is a picture from a Hubble image of the currently most distant known object in the universe. And so we're going to be using images and data from the near-infrared camera, where we'll stare for more than 50 hours at a time at different places, at distant places in the universe. And then we're going to use spectroscopy. We're going to split that light up to confirm that these objects are actually very far away. And so this is essentially what we built Webb for. We know this is one of the things that it's going to be doing in its first year. In addition to that, we're going to be doing surveys of galaxies, and these will be, if you will, the gold standard set for learning how these galaxies formed and built themselves and evolved over time. We'll study the sources that reionized hydrogen after the universe cooled and hydrogen became a molecular gas. Then stars formed, and the radiation from the stars began to reionize to separate the hydrogen gas to ionize them, pull them apart, and let the light from the galaxies through. We'll watch the universe do that with Webb. So one of the other things that not only astronomers are excited about, but that the public is excited about, is the study of exoplanets. What you see here is an artist's conception of a planet going in between its host star and us as we observe it. So we will explore the diversity of these exoplanet worlds. We're going to be looking for molecules in the atmospheres, molecules like water or carbon monoxide or methane or even carbon dioxide. And this is going to be, as you can see from this slide here, we're going to be looking at 68 different worlds by this so-called exoplanet transit technique, watching stars have their planets go in between us and them so we can learn about their atmospheres. And we'll actually also be taking pictures of stars, and that's what you see here. This is what it looks like when you take an image and you block out the light from a star, so you just see the small planet next to it. And we're going to look at 38 different stars to see some of their planets. And these are pretty famous stars. They actually have names like Epsilon Eridani or Beta Pictoris, Kappa Andromeda, and Vega. So between these two programs, this is nearly 100 worlds that we're going to explore. I think it's really exciting for people, particularly young people in this generation, that you live in a time when we really begin to explore other worlds. There were so-called ages of discovery in the past on Earth, but actually there were people pretty much everywhere. And so even when there was age of discovery, there were already folks there. When we go into the age of discovery now, we're going to be going places and studying things that humans have never seen before. So while those are two exciting things that a lot of people have heard about, I put this beautiful image up because a lot of people think of the beautiful nebula images from Hubble like this one. And this is to indicate another important facet of what Webb will be doing during cycle one, and that is looking in regions just like this, because this is where the galaxy forms stars. And so we're going to be studying systems of protoplanetary, pre-planetary disks, and studying the chemistry of water and organics in these forming systems. So this tells us not only how stars form, but how the associated planetary systems form with them. Well, speaking of planets, we've got a lot nearby us. What about our own solar system? Can Webb be used to explore that? And of course, you've heard that we can actually look at our own solar system, particularly those planets outside of Earth's orbit. So we're going to be looking at the Jovian system. We're going to study how the clouds of Jupiter are different as you look at them in infrared. And what you see depicted here is actually a ground-based infrared image. We can see a little bit of the infrared spectrum from the ground. And so this is from a ground-based telescope. And then Webb sees not only this, but even farther into the infrared to explore different regions of the clouds. We'll search for new moons because we've got a bigger telescope. And if there are even smaller moons, we'll be able to look for those. And of course, because we see the planet disks all in one image, we more or less have global weather satellite coverage for these planets in the outer part of our solar system. And I think, as I mentioned before, particularly in areas with reference to exoplanets, it's a very exciting time. I think right now we're almost in the before times. There'll be times when we understood the universe before Webb, and within a year we'll understand the universe very differently. So let me summarize the cycle one science. There's going to be more than 10,000 hours of observations with the world's newest, most powerful space telescope. There's over 400 individual programs, and these are science investigations of all the different topics, some of which I just touched upon. More than 2,500 people are involved in these investigations. So these are scientists all over the world. And nearly every aspect of astrophysics is represented in this first cycle. Right now, we're living in the pre-Webb world. We don't know what it's going to discover. But very soon, we will be living in the post-Webb world when our view of the universe will change dramatically. And this is tremendously exciting to all of us who've had a chance to work on Webb, and we hope to bring you along in that excitement as we discover new things about the universe. Thanks.